Hello friends, welcome to this channel Make Easy. Today we are going to study the subject heat transfer and the name of topic is transient heat conduction. In this lecture we will study about the basic formulas of the topic transient heat conduction. First of all, let us see there are how many types of numerical that can be asked in exam about the topic conduction. Let us see. Okay, there are three types of numericals that can be asked in the exam about the conduction. First one is steady state. The second one is unsteady state, that is transient conduction. The third one is heat transfer through fin. In this video lecture, we will study about the unsteady state heat transfer, or you can say transient heat transfer. Now let us check the definition of unsteady state conduction or transient conduction. It is a type of conduction in which the temperature of body changes with respect to time. Let us understand it by an example. Suppose we have a sphere of metal like this and we are heating this sphere of metal up to 800 degrees Celsius. Okay. Now we are having some water at 25 degrees Celsius temperature and we are putting this heated metal sphere into this water. Let us put it. Okay. Now we can say that the temperature of this metal sphere will be decreased with time. After some time it will become at 700 degrees Celsius, after some time 500 degrees Celsius, then after some time 300 degrees Celsius, and it will become 100 degrees Celsius. Okay, now we can say that the temperature of this metal sphere is changing with respect to time. So this is a case of unsteady state heat transfer, or we can say that transient heat transfer. Now we will see some important formulas of the transient heat transfer or unsteady state heat transfer. It is also known as lump heat capacity method. The first formula is Biot number. It is also called Biot number. Biot number is defined as HLC by K, where H is the convective heat transfer coefficient, K is the conductivity, and LC the ratio of volume to area. Let us check the values of LC for different solids. First one is sphere. The volume of a sphere is 4 by 3 pi r cube. The surface area of a sphere is 4 pi r square, and the value of LC will become volume upon area, that is 4 by 3 pi r cube divided by 4 pi r square, and it is r by 3. For cylinder, we know that volume and area are pi r square h and 2 pi r h, so that the value of LC will become pi r square h divided by 2 pi r h, and that is r by 2. And for a cube, the volume and areas are L cube and 6L square, so we'll get the value of LC as L cube divided by 6L square, and that is L by 6. Now here it should be noted that to use the lumped heat capacity method and all its formulas, the Biot number must be less than 0.1. If the Biot number is not less than 0.1, we cannot use any formula of this lumped heat capacity method. Second formula. To check this formula, let us have an example. Suppose we are having some water at 25 degrees Celsius and we are putting a heated sphere of metal at 800 degrees Celsius into it. After t seconds, means after some time, the temperature of the sphere will become 100 degrees Celsius. Now for this particular case, the initial temperature of sphere is denoted by Ti. The temperature after t second is denoted by capital T, and the temperature of water, that is ambient temperature or atmospheric temperature, is denoted by T infinite. So for this particular case, the formula is given by theta by theta 0, that is temperature difference after t time divided by initial temperature difference, or we can say that T minus T infinite by Ti minus T infinite is equal to e raised to minus HAT upon rho CV, where H is the convective heat transfer coefficient, A is the surface area of the solid, T is the time in second, Rho is the density of solid, C is specific heat of solid, and V is volume of the solid. And the formula number 3 is about time constants. The time constants is generally used for thermocouple. Its equation is tau is equal to rho CV upon HA, and the unit of a time constant is second. It should be noted that time constant is used to show the sensitivity of a thermocouple. Lower is the time constant, better is the sensitivity. Now let us have a brief revision of what we have learned in this lecture. First of all, we have studied the formula of Biot number, that is HLC by K. We know that LC is equal to volume upon area. The second formula is theta by theta 0, that is T minus T infinite upon Ti minus T infinite is equal to e raised to minus HAT upon rho CV. And the third formula is for time constant, and it is tau is equal to rho CV upon HA, and unit of tau is second. Thank you.